In this video, we're going to talk about the programming model that we're going to use for this class. We're going to use the event-driven programming model, and this is what's going to allow us to build the interactive applications that we want to build for this class. Coincidentally, event-driven programming is also my favorite programming model. All right, there's no coincidence here. I am one of the professors teaching this class. Obviously, I'm going to teach you one of the models that I like best. So let's get started learning about it. All right, so far the programs that we've written have sort of executed in this linear fashion. What do I mean by that? Well, the program starts, and then we run, blocks of code. Here's A, then B, then C, then D, and we keep going, and eventually your program ends. Okay, and each letter here, like A, this corresponds to some block of code. This might be the body of a function. It might be part of an if statement or the block of code after an if or an else or whatever. Okay, but after that executes, you know exactly what's going to execute next. The only thing that can change the flow of control of your program is the data. All right, so it doesn't mean that the programs execute exactly the same every time, right? With different input data, maybe I do A, C, G, H, Z, whatever, and eventually I end. Okay, so this doesn't mean that your program is exactly the same every time. It means that the flow of control is dictated by how you wrote the program and what the inputs are, so that when you get to the conditionals in the program, you know which way you're going to go. And I can write very complicated and very powerful programs using this model. Okay, now in this class instead, though, we're going to look at the event-driven programming model. All right, and what's different? Okay, it does not look like this above here. Instead, my program starts, I initialize everything, so I need to set my program up, and then I wait. And this is the key difference. My program effectively just ends and starts waiting, doing nothing else, okay? And nothing now is going to happen in my program until some event occurs. Now that doesn't mean that you can't wait up here. So imagine, block H here is looking for some sort of file input. So maybe it's waiting for you to type the name of a file in so it can read the file and then execute block C and move on from there, right? The difference is block H is waiting for a specific input. I'm waiting for you to type a file name. Down here, I'm not waiting for anything in particular. I'm just waiting. So any event can occur and I will respond to it. So sometime in the future, some event occurs. We'll talk about what events are in a second, all right? And when that event occurs, I run some function which is called a handler. That handler executes. When it completes, I go back to waiting. Sometime in the future, another event occurs. All right, I execute another handler, and this handler is probably different because that event was probably different. When that's done, I go back to waiting. So now most of the time, my program is just sitting there waiting. It's not doing anything. But whenever an event occurs, it immediately then goes off, runs a handler, and executes the code in response. Okay? Now eventually, to end my program, I get some sort of event that corresponds to quit. Right? Basically says you're done. All right? And then the program ends at that point. Okay? So the primary difference here is that on the top, my program just keeps executing code forever. On the bottom here, I keep waiting forever until events occur. This is a fundamentally different way of thinking about programming. Okay, to better understand the event-driven programming model, we have to talk about events. What are these events? Okay, and there's a bunch of different kinds of events, and it really depends on what type of system you're running, what the events of interest are. So we're going to focus today on the events that you're going to see in this class that we're going to use. All right, and I'm going to break them down into 4 categories. You're going to see some input events, keyboard events, mouse events, and timer events. And in these categories, there's actually some subcategories. The types of input events might be something like a button or a text box input, right? Type of keyboard events you might see are key down events or key up events when you release the key. On the mouse, you might see a click event or a drag event. And a timer is something that just happens periodically, right, no matter what. Okay, so these are the different kinds of events that you're going to see in our system. As we build games, you might push buttons to set up control. You might type things into a text box to give information to the program. As you're controlling your game, if you're moving something around inside the game, you might use the keypad to control, like the arrow keys, and when you push them down, you do one thing. When you release them, you do something else. On the mouse, you might click on elements of the screen and you might move them around similarly. So these are the kind of events that we're going to see in our system. And for each event that you care about, so for instance, let's say a button event, you're going to then write some sort of a handler. And you're not going to write one handler for all button events. When you create a button in your system, you'll write a handler that handles that particular button. Okay? So most of the time, your system, as we said, will be sitting around waiting, and when something happens, like a button gets pushed, then you'll go off and you'll run the handler. So let's take a look at our first event-driven program. Here it is. You can see it's pretty short. It's only 14 lines, including blank lines and comments. So we're going to be able to walk through the entire program, and hopefully we'll get a good understanding of what's happening. Now, we don't know how to build a user interface yet, and most of the events that I've talked about have to do with a user interface, clicking buttons and moving the mouse and things like that. So we're just going to look at a timer event. Now, timer events are critical for any event-driven program. As we've said, most of the time, the event-driven program is waiting, doing nothing. So unless you have a timer event that fires periodically, your program can't do anything unless the user does some action. So instead of waiting for the user to perform an action, we're just going to have the timer fire, and then we'll do something on our own. Okay? Now, let's look at the code. All right, so if I get to the first line that's not a comment, you can see on line 4 that we are importing Simple GUI. What's Simple GUI? Well, Simple GUI is a Python module that we've written for you to allow you to build interactive applications in Python. And in a future lecture, we'll cover Simple GUI in much more depth. For now, I don't want to get into it. We're just going to mostly ignore it, and I'll just give you the pieces of information that you need. Okay? Next, we're going to define an event handler. In this event handler, I'm going to call it tick. You can call it anything you want, but it's a function that takes no arguments, and it does something silly. All it does is print the word tick to the console. Okay? Next, on line 11, I'm going to actually register the handler. So this is where Simple GUI comes into play. I'm going to call a function in the Simple GUI module called createTimer. And as the name implies, this is going to create a timer. The first argument is the number of milliseconds that you want to occur between each time the timer fires. All right, so I put 1000 here. That means the timer event is going to occur once every second. The second argument is the function that you would like to call, or the handler that you would like for this timer event. And I give it tick. So this is the function tick that we're going to execute. All right. Then finally on line 14, we call timer.start. This starts the timer running. Okay, so let's run this and let's see what happens. Okay. Tick. So hopefully you can see that it's printing tick about once every second. And this is exactly what I want to happen. Right? I told it that every 1000 milliseconds you should fire an event. That event occurs. The tick function then runs. It prints to the console. Now, you're going to notice something here. I can't stop this program. There's no kind of stop event here. So it's going to keep printing tick forever, right? The way that I can stop this is actually hit the reset button in Code Sculptor. Now my program is done. All right. I want to point out one additional thing about what's happening here. You'll notice that after I call timer.start on line 14, the program ends. Okay, there's no more code here. The program is done, right? This is a key to event-driven programs where they just seem to end. That's when you go into that wait state. All right, and hopefully I've already convinced you that the program works because you saw that the tick was happening. But after the program ends, you go into that wait state, and then you start waiting for events to occur. And in this program, those timer events are going to occur, and then we run the tick handler, and it'll keep doing that forever. So there's one final concept that we need to understand in order to completely understand event-driven programming, and that is the event queue. All right. Now, there's nothing that you can do to stop two events from happening at exactly the same time. For instance, imagine a timer event fires at exactly the same time that a user pushes a button. All right. So how do we handle that? Well, the system handles it for you. So internally, there's something called an event queue, and you never see this, and you have no control over it. But it is basically taking events as they happen, and the system puts these events in this queue. So the click event happens, a timer event happens. Okay, a key down event happens, and so on. So as events happen in the system puts it into this event queue, which you never see. This all goes behind your back. Now remember, your program is sitting there waiting for an event to happen. So now what the system does is when your program is waiting, it looks in the event queue. If it sees an event, so right now there's a click event, it'll say, oh, let's take this click event, take it out of here, and let's figure out which handler to run. Now behind your back, automatically, it then figures out the handler, and then it runs the handler. Now your code is actually running. Okay, when your code is done, you go back to wait. The system then looks in the event queue, sees, hey, there's a timer here, I'll take that out, figure out what handler I should run now, and so on. All right, and it'll keep doing this until there are no events left in the queue. At that point, right, the system will then say, oh, there's nothing to do, you will wait forever until another event occurs. All right, and you can't control the order this happens, but it shouldn't matter, right? Your program should be written to respond to events and do what needs to happen when those events occur, no matter what order they occur in, right? And I want to make one final point. When this handler is running, nothing else can happen. If more events happen, they just go into this internal event queue, all right? So while your handler is running, you can't process any more events. So what this means is if you build a handler that is really long or maybe has an infinite loop in it even, then you're stopping all other events from being processed. This is going to make your program or your game very unresponsive. So just keep that in mind. Now you've seen the event-driven programming model. In this model, you first write your handler functions, and then you register those functions so that they'll get executed in response to some events. Your program then just ends. At that point, the system takes over. And while the system is running, your program is waiting most of the time. Whenever an event occurs, it first gets put in the event queue, then the system pulls these events out of the event queue one at a time and executes the appropriate handler. Right? This is why this is sometimes called the Hollywood model of programming. Don't call us, we'll call you. Right? You don't get to decide when your functions get called. Instead, the system calls your handler functions whenever the events actually occur. Just like a Hollywood actor who goes to an audition, gets told not to call them back, right? If they decide to choose him or her, they'll give them a call at that point. So you don't have any guarantee what order your handler functions will run. You just know that if and when the events occur, your handler functions will in fact run. And this is how graphical user interfaces are built. Okay? When you pull down a menu and select an item, or you push a button, these are events that invoke event handlers. Okay? And this is also how we're going to write the interesting interactive games that we're going to write throughout this semester. Now, I hope you come to enjoy this model as much as I do.